Next, we need to talk about the signs of trigonometric functions. So remember that sine is y and cosecant is 1 over y. So in quadrant 1, remember we have 4 quadrants, numbered counterclockwise. In quadrant 1, sine is positive because y is positive. It's also positive in quadrant 2 because y is positive. Y is negative in quadrant 3 and in quadrant 4. So that means they're going to take on a negative value. So sine and cosecant are negative in quadrant 3 or 4. Now let's think about cosine. Cosine is x, secant is 1 over x. X is positive in quadrant 1, but negative in quadrant 2. It's also negative in quadrant 3, and then it gets positive again in quadrant 4. So that's why it goes positive, negative, negative, positive. Tangent and cotangent, remember tangent's y over x, and cotangent is x over y. So they're only going to be positive as long as x and y have the same sign. So in quadrant 1, tangent and cotangent are positive because both x and y are positive. In quadrant 2, here we could label it like this. In quadrant 2, they're going to be negative because x is negative and y is positive. Quadrant 3, both x and y are negative, so cotangent and tangent would be positive. And in quadrant 4, when I've got x is positive but y is negative, again because they've got different signs, tangent and cotangent would be negative. If this isn't your favorite way to visualize what values tangent and cotangent will take on, I did go ahead and put this image in. It's also in your text. So you can see where sine and cosecant are positive, cosine and secant are positive and negative, and the same for tangent and cotangent. It really depends on the x and y values. So let's find the quadrant in which this particular angle theta lies. So we have our quadrant 1, 2, 3, 4, right? I have that sine of theta, which is y, is less than 0. So where would sine of theta be less than 0? Well, my only options are quadrants 3 or 4 because that's where y is negative. But then I also have that cosine of theta is greater than 0. Well, cosine is x. So where is x greater than 0? Well, that's only going to be in quadrant 4. Let's talk about identities. First thing I want to do is introduce the reciprocal identities. So cosecant is 1 over sine of theta, and this should kind of like make like a guttural sense, right? Because cosecant's 1 over x. So if I have 1 over sine of theta, which is x, I get 1 over x. For secant, nope, it's y. Sine is y. Sine is y. I will remember this. For secant of theta, I have 1 over cosine. Well, secant, remember, that's 1 over x. And cosine is x, so I've got 1 over x. For cotangent, it's a little bit different. I've got 1 over tangent. Well, cotangent is x over y. Tangent is y over x. But if I have 1 over y over x, I have to keep the first fraction the same and flip the second fraction. So I do get cotangent. I get x over y. So these 3 identities should kind of feel comfortable. We also have the quotient identities. These are only for tangent and cotangent. Remember that sine is y, cosine is x. So we have tangent and cotangent defined here. What we're trying to build up to is with an unknown theta, if we are given a couple of our trig values, being able to determine the remaining of trig values for our 6 trigonometric functions without knowing our theta, which we can do, which is cool. So what we're going to do now is example 3. And I'm going to change colors. So what we need to do is find an exact value using identities when only the sine and the cosine are given. So if sine of theta is square root of 2 over 2, which is y, and cosine of theta is square root of 2 over 2, which is x, I bet you can guess what this theta is. Well, this theta would be 45 degrees or pi over 4 or any addition of 2 pi to that, right? Because that's when sine and cosine have the same period. So tangent of theta would be sine of theta, cosine theta. So square root of 2 over 2 over square root of 2 over 2, which is 1. Cotangent of theta would be cosine of theta over sine of theta, which again would just give us 1. Cosecant of theta is 1 over sine of theta. So I have 1 over the square root of 2 over 2. That gives me 2 over the square root of 2 multiplied by the square root of 2. So I'm left with the square root of 2. Secant of theta is 1 over cosine theta, which is 1 over the square root of 2 over 2, which is the same as cosecant, so I already know the answer is square root of 2. And there we've found the values of our 6 trigonometric functions. The last 3 identities are the Pythagorean identities, and these come from our unit circle, right? I've got x squared plus y squared equals 1, right? That's kind of the same as sine and cosine, because sine's y, x is y. So I have that sine squared of theta plus cosine squared of theta is 1. Tangent squared theta plus 1 equals secant squared theta. And cotangent squared plus 1 is cosecant squared of theta. So these are our Pythagorean identities. Here they all are together. The top 5 are kind of like a gut instinct, right? They're good for us to know, right? We know them in our gut by the definitions of the 6 trigonometric functions. It's the Pythagorean identities that we really need to work on committing to memory and knowing how to apply to problems and problem solving.